If we take a look on this video, we can see and remember that for many thousands of years people used wood to make houses, and basically all houses were made from wood. Which drawbacks can you name, and how do you think, why did we switch from wood to stones, bricks, metal, concrete and other materials, and why we don't use wood as much as in previous times? So if we would like to name those properties, the first one would be fire resistance, because in Middle Ages, as you remember from history lessons, if there was a fire in one building, then not only this building burned down, but all the street or all buildings in that city burned down in just few hours. So fire resistance is one of the biggest drawbacks to wooden structures that we have to consider. Next one is earthquake resistance and wind resistance, because concrete and steel structures are more suitable for buildings that are made in seismic regions, so this is also one big drawback. Now with modern woodworking technologies, it is possible to design and build high-rise buildings in terms of quality, resistance, durability and safety. Those buildings will be compatible with those made of concrete and bricks. But it's important to question how we build, because buildings have such a large impact on the amount of resources that we use. So what we have to question? Sustainability. Is it sustainably to cut big trees to build some kind of building? Is it good for forests? Is it economically viable? Because if this building will cost 2 times more than concrete building, where's the point? What are ecological benefits? And what are CO2 emissions? If we take a look on that diagram, we can see that 33% of CO2 emissions is due to industry of all fabrics that we have. 28% is due to transportation. The biggest part, almost 40%, is due to buildings. Either residential and commercial buildings gives the biggest part of CO2 emissions in our atmosphere. So now let's compare wood properties with those of other materials. So if we take a look on how metal and concrete is made, in that case you can see this picture where you have to mine those materials like metal. You have to dig them from the ground, and there is a big quarries where it is done. So there is no greenery. The technological process of melting that material and creating some kind of beams from it uses a lot of energy. We have to heat it to the very high temperatures, and this is also warming our planet. Down there you can see how concrete structures are made. Of course, there is not so big heat necessary to make concrete columns or beams, but as you can see, there is also steel elements inside, so they were made before. If we compare it with wood, then we can say that wood comes from renewable resources. So if you cut this tree down, you can plant a tree instead of this one. In Latvia we have such a politics that if you cut down a tree in the forest, you have to plant instead of it 2 new trees. Of course, some of them won't survive, but others will, and in last 30 years there is no decrease in forests in territory of Latvia. While you are using wood, it is very clean, you don't pollute air and water, and you can use 100% of this material. All leftovers you can use in other projects, or just you can make briquettes out of those materials and use as a firewood. It is light material, so it's easy to transport it, it's easy to make constructions out of it, because you don't need heavy cranes to move those wooden parts around. and it's recyclable. Any piece of wood you can just throw out in landfill, let's say, and it will rot very fast, so it's reusable, recyclable, and biodegradable. And it has lower energy requirements for manufacturing. And while this piece of wood is solid in a form of round wood or cut in boards, it contains all carbon inside it. So it won't release it to the nature while it's not burnt or rotten. And if you take a look on that strange table, then you can see those main material: steel, blue line, brickwork, red line, reinforced concrete, green line, and this light green color, this is wood. So if we talk about costs, we can see that steel and brickwork is still more expensive than using wood. If we talk about water pollution, then we can see that with wood you have the least water pollution if you compare it with any other materials. Deforestation, of course, you have to cut trees if you use wood in buildings. But as we were talking before, if you think sustainably and if you plant new trees, then this moment is not so harmful for the planet. And if we talk about dust, there is no dust when you work with wood, and energy consumption is very low. Any other material will consume much more energy than wood. After that, we can start talking about mass timber. These are those really big and massive components that are used in our days. If we compare it with wood that we use on daily basis, like those on the right side, small pieces that are used for home building and other structures, we can think about what happens when it is massive. How can we shape it? What will be the structural performances of that material? How do you think which construction method gives capacities to make large-scale building projects? And how do you think which of them is better in case of fire? Fire is the biggest drawback in wood constructions, so there are a lot of different tests made to test wood properties in case of fire. Studies have shown that wood itself has high fire resistance since it protects itself by charring. Despite the spread of flame for a long time, there is little destruction of wooden structures. Here is a test done in a laboratory where one CLT plate is burned from one side for 2 hours. This side was burned, and this side you can see that this wood structure is in very good shape. It has all its structural integrity. So what happens here? As you can see in section, there is char layer that is completely destroyed wood, but it is still here and it doesn't let fire to go deeper inside of this wooden structure. This is pyrolysis zone, damaged wood, but it still holds, and this is completely unburned wood, so it has all its properties as a new material. So what can we say? 18 centimeter thick wooden floor made from laminated timber has fire resistance more than 2 hours. So we can burn it for 2 hours and it will still has its properties. In 2 words, what is cross-laminated timber? It is something very similar to plywood. Plywood is thin veneer of wood that is glued together in perpendicular directions that gives very good properties. It is very stable, it won't expand or contract in moisture, it won't split. The same with massive wood, just this height is not 1 millimeter, but let's say 3-4 centimeters, and if you glue those boards together in perpendicular directions, this cross-laminated timber will have very good properties in terms of strength and fire resistance as well. Now I would like to show you test that was made in Oregon State University about wood properties in case of fire. They were testing CLT plates from two different manufacturers. They were planting much more those temperature detectors in order to understand how the char layer works and how heat progresses through that layer and impacts unburned wood underneath. They used thermocameras as well to see are there any hot spots that heats faster than other places. These results was very promising. If we take a look on thermal camera, there were no suspicious like flashes or other transmission of high temperature in any place more than in other places. They were testing 6 different plates and they proved that material holds its structural integrity until the test was successfully finished. And this is CLT panel in real life. You can see there are no voids between those boards, so fire can't get inside and burn from inside. And here you can see CLT floor after fire test in horizontal position. Now let's compare it with concrete structures and with metal structures, because as we can imagine, those are materials that are more durable in case of fire. Let's take a look how it is in real life. In those pictures you can see structures made of concrete. When they are exposed to fire, they literally fall apart to the state of sand. As you can see in case of this column, just this metal structure holds its integrity. And in those cases you can see that because of fire, this structure doesn't hold even itself. It is bending downside, so we can decide for ourselves, is it good material in case of fire. Next one is metal structures. In that case you can see that those beams are bent, and I can tell that in that parking place there was a fire that lasted less than 1 hour. Hot air was going through that column because there is a hollow space inside. This temperature went so high that this column lost its structural integrity and bent under the weight of the ceiling. And if you take a look, there is other column back there, it is bent also. So in case of metal, it also can lose its properties. We can't say that any of those materials is very good in case of fire. What we can conclude when we are talking about wood: it burns very slowly and very predictably, and it maintains its inner core, this part. And as you can see, this char layer here protects the inner core from the fire. If you will put wood in fire, it will burn. I'm talking about mass timber. But it will burn while there is a wood exposed and there is a burning source. So if you will take away that burning source, fire for itself will just stop, partly thanks to this char layer that doesn't let fire to go deeper. In those pictures you can see original beam that was tested for 2 hours. It lost a lot of its material, but it still has its cross section. So if you size the beam, so after 2 hours or whatever structural safety has to be, it will burn really slowly and a char comes around and protects its inner core. Certain amount of material is going to burn off, but you can size it, so whatever shape is left cross-sectionally still has equivalent structural strength that you need for the building. So in that case, if this cross-section is still holding the structure together, you can just put bigger beam and then you are sure that this beam will hold 2 hours of fire without any structural drawbacks. In those cases, you can also see that after 2 hours of fire, all those metal elements are not damaged. And in case where you can see that this beam was screwed to the ceiling, from that side it is almost untouched. And of course there are tests that are made in laboratory to understand how thick this CLT panel has to be to hold all structures that are on top, and what its thickness has to be in case of fire to withstand those, let's say, 2 hours of fire and still hold all weight it has to hold. I would like to make a little conclusion about this theme. At the moment there is a little lack of knowledge about modern wood technologies. Mass wood has fire resistance properties based on the fact that wood chars, and charring of wood is like a natural protection from fire. And if we compare, steel or concrete is considered not combustible material, but wood is considered to be a combustible material. But if you compare those materials in its raw form and you don't protect steel or concrete by drywall or paint, in that case wood will outperform steel or concrete. Steel will melt and fail, concrete will lose its structural integrity, mass wood will char to the point and then it will stop. In many cases it's safer material than steel or concrete. The most people fear of fire and wood has to do with standard 2x4 wall constructions. When we make our houses with those big voids between those 2x4s. In that case, it will burn down in case of fire. But if we have solid timber, we don't have those empty air spaces where fire can go in. This char layer that forms in case of fire is very predictable and measurable layer that we can include in our measures to understand what thickness of timber we should use in our projects.